So now we are on volume 5 of the AI Awareness and Ethics presentation. And here actually in this volume we're going to talk more about the technical concepts behind AI. We're going to discuss a little bit about different kind of algorithms and how they apply to different technology. You might find this these slides here, a little bit technical. You do not have to worry about it. The idea is just to get familiar with the keywords that they would be used in general. You might hear it from different people. So I just want to give you a little bit of be like in comfort zone when you hear these terms. So I was asked before to give some kind of information or insight about, what new skills or new profession that will be required as being we moving now into that AI global kind of usage. So we're not going to talk now about what profession that will not be required because it's hard to predict that. But the one that would be very highly marketable and requires a lot of skills, it's called data scientist. That's a person that has a combination of computer science, math, statistics, calculus, probability. Someone understand math very well, understand computer science, have the skill of Python language, which is now the language for AI, similar to Java and C++. So that kind of profession actually will have a great future and will be very marketable, not only in Silicon Valley, but all over the United States. So I'm giving you here example of what data science is about. So we have the big or the circle, the output circle, which is everything about artificial intelligence. Part of that, a core of artificial intelligence is the machine learning, as we see before, which will have the algorithm and the training from the data scientist. And within the machine learning itself, there is a smaller circle, which is the deep learning. So deep learning actually, because it's a process, it's a very sophisticated process that will take thousands of information and be able to train the machine and come up with output. So that's why, it seems like a smaller circle, but in reality, deep learning is very deep, very sophisticated, takes a lot of time to execute, also take a lot of energy. I'm talking about power here, electricity, to keep the servers up. So that's part of deep learning. Then there's the data science, which really goes over all the circles, but there is also more outside of the AI because of the math and the statistic part of it. So that you see now the circle that says data science. This is the new skills that's required now in order to be able to join, I guess, the staff of AI scientists and developer. So this slide, actually, we spoke about it earlier when it applies the machine learning to different applications or different industry. We learned about how to use the AI in healthcare. and it seems like, it's making a lot of progress in that area. But there's also something very interesting. I just, heard about it recently about, how to apply AI in healthcare. So they're looking at the AI techniques in order to come up with the priority list for the people who are waiting for organs transplant. And that's based on the seriousness of illness, about age, about conditions, about different things, different categories that the researcher defined in order to come up with who should be the next for that transplant. So, I mean, this is really a great field, and it seems the scientists are making, a lot of progress there. It's also used in autonomous car, and we talked about, or we're going to talk about how to apply it in Tesla and other cars that is self-driven. And also we talked about in finance and, how the investment consultant use the AI to predict the market and to come up with the right portfolio for a specific client. We also talked about language processing, where it can translate from one language to another. And also we spoke about, image recognition or the face recognition, which could be used in a lot of things. Even the FBI can use the face recognition if they're looking for a specific person who committed some crime, but they can compare his picture with many other pictures to identify that person. So there's a plenty of areas that the machine learning algorithm can be benefit us. And we're going to talk a little bit about what is machine learning, what is an algorithm. And as I mentioned earlier, you do not have to worry about the technical aspects of it. This is just a way to get you familiar with some of the keywords, and you just to see how the scientists applying it in different applications. So some might wonder about where the scientists came up with the idea of artificial neural network. And actually the answer is very simple, because they got that idea from our brains, the human brains. So for quite some time now, both computer scientists and neuroscientists work together at Silicon Valley to understand the human brain, how does it function, and to be able to mimic that kind of concept in artificial neural network. So as you can see, I have here some pictures of the human brains. The one on the far left is a complete picture of the head, but then I'm trying to take a smaller portion of it and try to magnify it. So the one on the right, it looks like a tree, but actually it's a section of our brain, but magnified. So you can see the different nodes and how they are all interconnected and linked to each other. And we're going to understand when that link becomes active and where it becomes disabled. So generally, the neural network is actually a computational model. It's inspired by the way the biological neurons work in the human brain. And as you can see here, the bottom picture where it says deep neural network, this is the AI neural network. So it consists actually of different layers. The first layer is the input layer, and goes all the way. Then it has hidden layer 1, hidden layer 2, and then the output layer. So the hidden layers actually are the ones that has all the mechanic and makes that kind of computation based on what exactly the machine trying to solve or recognize. So the neural network here, we're showing only 2 level or 2 layer, but in reality, actually, this number of layers could be 1,000. So that gives you an idea about when we say the AI is expensive kind of model, it's because the type of energy required to run these kind of models. And then you can see that there's a connection between each layer and the layers that follow that to the next layer. So if we start from the input layer, there will be a link from each node to all the nodes in the second layer, or the hidden layer number 1. Again, and also from hidden layer 1, all the nodes are interconnected to the layer, the hidden layer 2. So these layers are actually, or the nodes are interconnected. That process and learn from data, it's kind of enabling tasks such as pattern recognition and decision making in machine language or machine learning. So as I said, it consists actually of 3 types of layers: an input layer, 1 or more hidden layers, and then output layers. And each node in these layers is connected to other, and it has associated weight and threshold. And if the output of a node exceeds the threshold, it activates and sends data to the next layer. So in a way, it says that if one layer has an influence on the second layer, that connection will be activated. So on this slide, we're showing how to apply a neural network to face recognition. So the input here is George Washington picture, and we want the model to recognize the picture, and at the end, the output would be George. So earlier, the data scientist or the person who trained the machine loaded hundreds of pictures for George Washington. You can see them down at the bottom of the page on the right hand, all the pictures for George Washington. Now it's testing the model to see if it can recognize the input. So the first step it goes through is, as we said, the first layer is the input layer. And here the image itself, as you know, it's all consists of a lot of pixels. So here there would be like a dark pixel versus light pixels. So each of these pixels are loaded. Now, the old days before this technology, before AI, when the computer tried to recognize a picture or an image, it used to go by comparing pixel by pixel, one pixel to another pixel from the other picture. But then this method doesn't really show accurate results, because like if the image or the head of George Washington was in the middle in one picture, and then it's on the right corner or left corner in the other picture. So when you try to compare pixel by pixel, it will not work. It would say not George Washington, although it is George Washington, it's just a different position. So here with deep learning and a neural network, they try to find his picture by looking at the features of his face. So everybody has, specific features for his face. So the nose looks specific way, the eyes, the mouth, the hair, all of that is different features for George Washington. So after it recognized the pixel and know the dark and light ones, it identified the edges, because when the pixel move from black to white, the next pixel to it is white, that means there's an edge, and the edge is part of the feature. And so if the node does really reflect a specific feature of George Washington, it's going to pass the link to the nodes in the next layer with high weight or high attributes. I just want to repeat something I said it before in the slide before that about the attributes or the weight. In ChatGPT, there are so many attributes in the model that I believe it's more than 1 trillion attributes. So the models here are very, very sophisticated, very, very complicated. And that's really I would say the backbone of the AI, because of the concept of deep learning and the sophistication of that model. So back again to George Washington. So we identify different edges, and then the next layer will help us to identify combination of edges. So try to make sense out of different edges, if that edge will reflect a specific feature or not. And then the last one will be identifying the features of George Washington. And as you can see in the bottom, you start seeing that the pictures start to look more and more clear. So, you can see the nose now, you can see the hair, the eyes. So when it went through that, it was able to identify features of George Washington that are similar to the features that in the images that the data scientist loaded before. And then at the end, it says, if it all passed and the picture is really matching one of the picture in the memory here, it will say the output is George. Now, saying that, if you feel the concept here is a little bit difficult to comprehend, a little bit sophisticated, it's okay, because each algorithm is really considered as maybe PhD research papers. So it's very deep, it's very mathematical, a model and statistic and computer science. But if you have interest to know how these algorithms even work in more details, I'm sure you can really look at it on YouTube, and there are thousands of videos that explain each one of the algorithms that we mentioned before. But again, this is for people who are really in that field and can grasp the idea of deep learning neural network. So as I said before, when I talked about algorithm, and I defined as being actually the backbone of AI. So an algorithm is actually a set of well-defined instructions, and it's designed to perform specific tasks or solve a particular problem. And these instructions that the algorithm address are executed in a sequence so to achieve the desired outcome. And they are very fundamental for AI. The reason I'm showing you this slide, because I want you to see how the algorithm take the input layer, the hidden layers, the result from the hidden layers, and the outcome of the output, and it takes that and come up with some kind of function. We call it the activation function to allow the outcome to look like the probability of how close that outcome close to the correct answer. I also want you to see there is a factor here or a constant here, which is b. So let's just take it from the beginning. So the way the algorithm works is it takes the each node, the value of each node, multiplied by the weight or the attributes that goes from one node to the next node for the next layer, and take all of these and add them all together, the summation of all them together, and then adding the bias, and we're going to talk about the bias later. But then take all of that and go through what we call activation function here. And that activation function could be sigmoid, or could be tan or cotan, could be, a specific formula. So the reason we're doing that is we want to define non-linear function, because most of the results or the outcomes is not really going in a linear way, but they are scattered everywhere. So it's not it's not a linear function, or it's not a linear result. So which is the way things are, and that really will help to understand how close these results or the outcome to the actual result. And remember, this is all happening at the time of the training. So in some cases, the data scientists know what should be the outcome, so they can compare the outcome of this algorithm to the actual result. So it's a time now that we need to talk about biases in the algorithm. So biases could be used in a healthy way and also in non-healthy way. In healthy way is when the trainer know what should be the outcome. So he's trying to put some kind of extra influence on one particular factor versus the other. So he add that biases to the algorithm. But it also could be used in non-healthy way, and that's where our concerns are. For example, if we're talking about healthcare, there was a lot of talk about using AI to be able to decide who should be the next patient who is waiting for specific donor or organ. So if someone is waiting for, kidney or liver, and there's a list of people, they were thinking to use the AI to decide who should be the next one to receive that organ. But in some cases, if they add a biases to the equation here or the algorithm of the AI, that bias could be used to discriminate for one group or ethnic group versus the other. So some biases might say, give all the white men over 40 is the priority to get, that organ versus the other people, or for specific ethnic group versus the other. So that's the kind of biases that we do not approve of, and we need the government to be aware that we are against using biases to discriminate for one group versus the other. Also, biases sometimes is used in ChatGPT. I think I mentioned maybe an earlier slide that one kid or student was doing his research and asked question about the Coptic history. What went wrong with the Coptic history? So the ChatGPT came up with many points that really went wrong in the Coptic history. So he asked the same question, but for different faith. But the result came back that this unethical question, and we cannot provide you for an answer. So clearly, someone put a bias for, to discriminate against maybe Coptic Church versus the other. So that's why we need to remind the people who work on regulations that they have to be careful about the biases, put rules or regulations around it, so all the data scientists and people computer science aware of it and abide to it. So if you have a question about what's the difference between weights and biases, because the two of them have a way of influencing the next layer of neurons about the outcomes. So here I'm showing you the difference between weights and biases. So weights actually control the signal or the strength of the connection between two neurons. In different way, a weight decides how much influence the input will have on the output. And in another way, the weight could be also some describe it as attributes, and this attributes or this weight is the link between two neural network, and based on the first layer. If the first layer has any kind of impact on the next level, the weight will be higher or the attribute is higher. But if it doesn't have any significant impact, the weight would be 0. Now the bias is something different. The bias is the neuron itself will always have the value of 1. But then the bias unit is not really influenced by the previous layer. So they don't have any incoming connection, but they do have outgoing connections with their own weight. So the bias could be a constant number as 100 or 1,000. And since the neurons is always 1, that means, whatever bias value we have, that would be the output of that neuron, and it's going to influence the layer after that based on how much weight that bias will have. So that's why we said, we need the government, we need the regulations to make sure that the bias are not used in an ethical way to make a preference to what one gender versus other, or one race versus the other, and use maybe for to train a machine on finding or detecting an image or doing any function that's required for the AI to do. Some might ask, what's the difference between machine learning and deep learning? And actually, this is a very good question. With machine learning, usually there is a human intervention here, and the person here is defining the different feature for image recognition of a specific object. So if you look at the graph I have on the screen now, there's a duck, and the idea is to recognize that it is a duck or not duck. So there's a human here that defined the feature of what the duck looks like, the shape of it, the nose. And then after that, it goes through kind of classification that will help in putting the pattern together and the features so it can define the duck. With deep learning, that human intervention is not there. The machine itself, through deep learning, through classification, through different process, will be able to come up with a good recognition for what the duck looks like. Again, like, their nose, the shape of it, the neck. And then based on that, they will be able to recognize if this is a duck or not duck. So it's a little bit complicated kind of science here, but the idea is deep learning is moving fast and helping us in defining a lot of things, solving a lot of problems. And doesn't require even human coding. So the algorithm will have that loaded to the transformers, and it just being enabled when there is a need for to solve any kind of business situation.